Hello, everyone. In this video, I want to talk a little bit about perspective as relate to architecture and creating sort of a photo merge between something you might have 3D modeled like the house we see here and an actual site photo like the landscape I am showing behind it. Now, it is a very common thing to do in architectural renderings to take a building that you've modeled and put it in its actual site. And I have a whole set of videos of how to specifically do that with all the tools. That's not what this video is. This is about really understanding perspective. What I find is, especially with students, but even professionals who don't have a lot of experience with perspective, they will often mess up the perspective of the image. And so I've got actually three takes of putting this house in this landscape right here, one, two, three. And my question is, which one is correct? Now, if you think they're all correct, that is not true. There is only one perspective that is correct, and it is because of perspective. So it is actually the middle image. I'll blow this up here in a second, but the middle image is the one that is correct perspective. This is wrong. This is not correct. And this is not correct. Now, I see that with my eye pretty easily because I have some experience doing this, but I do find people who are less so, they might say, oh, this looks good, I'm going to use that. And it's not right. You got to fix it. And same with this one over here. This one's too low and this one is too high. And this is important. Even though the computer is great, things like 3D modeling, this happens to just pretty much be SketchUp output. It's not a fancy rendering of any kind. That's not the point of this video. Just meant to be looking at placing a building in the image. And you do have to think about it. Just because a computer made a 3D rendering does not mean you can just drop it in anywhere and have it be correct. It's different than constructing a hand perspective. I find students, young professionals struggle to translate what they learn by drafting or drawing a hand perspective into working into a 3D computer environment like this, because you almost work backwards. When you're drawing by hand, you often start by starting a horizon line, talking about where the vanishing points are. If you're drafting it, you put down a plan and put a station point in, all those complex things down. But you start with the perspective geometry and you can work from there. When you work like this, you actually work backwards because the 3D modeling software has already given you a set of perspectives with horizon line, vantage points, and all of those things. And the photograph you've taken of the site already has inherent to it horizon lines, vanishing points, and all of those sorts of things. And so it's easy to skip that step and merge them together and do it incorrectly. The reality is what you have is a drawing, and you have to reverse engineer it out and find, particularly, you have to find the horizon line, because in any image there's only one horizon line, and all horizon lines between all the elements must match. And the reason why this one is wrong is because the horizon line of this building is lower than the horizon line of this image. And the reason why this perspective on the right is wrong is because the horizon line of this building is above the horizon line of this image. And the reason why this is correct is because the horizon line of the building and the horizon line of the photograph are the same, or approximately so, because in Photoshop you're only going to approximate things. And so that is key. So you have to reverse engineer the horizon line and match them all up. That's key. If you do that, then you will have a good perspective. The reality is I could scale this and move this house around. As long as I'm matching horizon lines, I am good. And we'll take a look at this here in a moment. So I'm gonna take the correct one and make it larger here, and minimize the ones that are wrong for now, and so we can just sort of get the full view. So the question then becomes, how do you find the horizon line of these images? Working digitally, I find that is the first step that is often has to be used. And since we do have two images here, essentially I have to find both horizon lines. So let me start first. Talk about ways of finding the horizon line of the background image, and then we'll talk about ways of finding horizon lines of the building. We'll find them both and then match them up. Now, there's actually several ways that you can find the horizon line of each. So the first thing is, you'll notice that I'm taking an eye-level perspective. I often find in architecture that eye-level perspectives are really the best, although you might not capture the whole building. In an eye-level perspective, it really is how people see buildings, so it is a good approach to use. And fortunately, eye-level perspectives also offer the easiest and most straightforward way of finding horizon lines. Also, like if you're out on a site and you're taking photographs of a real site, you're going to take eye-level photographs naturally anyway. I have been on projects where we've had tools to get us higher in the air for certain reasons, and you can follow similar steps for those. But usually you're dealing with eye level perspectives because of convenience, and actually I think it's the best to deal with anyway to show architecture. So here we go. I know I took this photograph, and how do I know where the horizon line is? Well, the straightforward answer might actually not get you the correct one, because there is a definition of horizon line that is just the difference between the ground and the sky. Now, I sort of see a big difference here. That's not the horizon line, though. That's top of a trees on top of a hill, right? And so this is the difference between ground and sky, true, but so it is a horizon in sort of that sense, but it's not the horizon line as defined by a perspective. Um, Also, this line down here, which is the end of this hill, may not be either, although it's probably getting close to the correct horizon line. It's not going to be the correct either because the ground continues. It's just sloping up. It's sort of a hill in the background here going up, and these are just the start of some trees. So it's probably really the real horizon line is probably somewhere close to being in between sort of those 2 points or thereabouts. Again, the reality is this site that I'm particularly chosen, there's lots of undulations in it. So it gets trickier when you do something like that. So those standard definition of horizon line is not what we mean by horizon line perspective. We have to find another way of finding it. So the one simple way is if you have an eye level photograph, and if you've taken the eye level photograph perfectly horizontally, it's actually going to be the middle point of your photograph. So if I took, say, grabbed my ruler and pulled straight down to get a guideline, and just let it snap. It'll snap to the center point of this photograph when you feel it going there. There you go. It'll go right there. So that's probably pretty close to the horizon line. You can see that starts to match what I knew generally is going to be somewhere in the zone based on the photograph. It's actually closer to that line than I thought it would be. I think, again, because of the sloping hills, but that's one go, and it might be close enough. Probably would be close enough if you do this. But I do find, like, when I'm out taking photographs, I'm not really necessarily paying attention. Am I holding the camera perfectly straight? And if you're not, it's not going to be perfectly the center point, but you're pretty close. And maybe you don't want to take a picture of perfectly straight anyway. So there are other ways of finding the horizon line of the photograph. Another way is if in the image there are sort of typically man-made objects, you can actually just trace those out and find the vanishing point. Now, any piece element in a photograph or a 3D model might have a variety of vanishing points. You know, buildings typically have two, one for the X direction, one for the Y, but but it might not, because there can be any angles. Any angled wall or surface is going to have a different vanishing point. However, all vanishing points do end up on the horizon line. So I picked this particular image for this study because it has a road and it's got some wires, both of which have vanishing points, and I, in theory, can use them to trace out where the horizon line is. So I could say trace the edge of this road, which is not perfect, but you know, it's pretty good. And actually, if I trace it out, I can notice I want it wherever the line on this side and this side meet will be a vanishing point. And I just using poly lasso, and I can eye it because, again, it's Photoshop. It doesn't quite have to be perfect, but I can tell if I go to about there and click and pull down, that's going to pretty much match the other side of the road. I'm a little bit in the gutter, so I can make up for that. Or I could edit and try again. But it looks like, based on vanishing points of the road, my vanishing point, you know, the horizon line's a little there, which is a little bit lower than where halfway through the photograph meant, which meant when I took this picture, I rotated the camera a little bit. Nonetheless, it's fairly decently close. So I could it's probably more accurate, by the way, to do it on a vanishing point. So I could set this selection set closed just temporarily, and I can come to my move tool and I can set it down to that point to perhaps get a little more accurate. And I'll just deselect it. And I can just verify and see. I don't know what's really going to happen if I trace the edge of this wire out and sort of get it straight in that line. In theory, if the wires are horizontal to each other, I should be able to come back up. I can take it right to the horizon line because there's only one horizon line, but and find its own vanishing point and sort of take it up to the top wire. And I can see, indeed, that vanishing point is really parallel to both of those wires. So therefore, I'm pretty confident right now that my horizon line is pretty well set based on those objects, and finding a vanishing point for any set of parallel lines and marking that as the horizon line. That certainly is the most accurate way to find your horizon line from an image. Now, There are other ways, because sometimes if you're really in a rural setting, you might not even have anything man-made, with anything without parallel lines, in which case you might need to rely on the halfway point or some others, because like maybe you don't know, maybe you didn't take the photograph. What would happen if you took the photograph and someone cropped it because you found it online, or someone else took it? Well, it's not going to be halfway through the image anymore. Certainly the vanishing point theory still works, but again, what if there are no roads, no fences, no wires? Are there other ways of finding the vanishing point? The answer to that is yes. Though again, they might be sort of estimations. So one thing I can do is, I'm just going to pull this guideline up so we can talk about it. One thing I can do is I can see these trees and these bushes in the background. I can say, well, we're going to take a look at this in a little more detail in a few minutes. But if it is an eye level shot, a human eye level, uh, no matter where they're at in the image, their eyes will be at the horizon line. Yes, certainly there is room for variation, because human are slightly different sizes. Some are taller, some are shorter, but from an estimating point of view, your eyes are at the horizon line for an eye level shot, no matter what. Of course, changes in plane or elevation change that, but on the ground, on a flat ground, that would be the case. So I can look at this image and say, well, if I imagined a person standing out here, where would their eyes be? So I could go and I could take a line down and be looking at the trees or looking at the bushes and say, you know what? I think it's probably around there. And I know we already looked at it, but I know I'm really, really close to where I set the horizon line before. So I was just looking at like this bush right here and saying, yeah, if a person's standing there, that's about where their eyes are going to be. Or at this tree, like, branches of a tree are going to be, this probably looks like a head hitter. It's been cleared out a little bit low, but low branches, you have to duck a little bit to get under. So I'm just using that as clues to guess where the eye level is. If there's a fence in the picture, you could do it the same. Or at best, if there really is a adult person in the photograph, you can drop it right on their eye level and you would match it. So matching it that way is a sort of a third way, the least accurate, but if that's all you have, it perfectly works well, because again, things don't have to be perfect in Photoshop, but they do have to be good enough. So we'll set that there as our horizon line. That's of the building. And I'll turn that off, and I'll turn on my building. And what we have to do is your building will be copied and pasted in, and it'll come in any location. It might even be a different size. You might scale it down or scale it up to fit your photograph, which is perfectly fine. That doesn't actually change where the horizon line of the building is on. I'm going to keep this the same size just for demonstration purposes. And so, like the site photograph, the most accurate way of finding the horizon line of a building is to trace out vanishing points. So I could sort of zoom in on this a little bit, and I could say take my polygon lasso tool. I could come up on a plane here somewhere, and then I could sometimes I'll just set it. There's different. I show in the actual videos on how to do this more specifically. I don't want to go into all the technical content in this video, but I could draw a line. Actually, I'm going to do it slightly differently as I think about it. I'm going to go to a brush really quick and just make a rather small brush. I want to keep it set for a while. So I'm going to come here, and I'm just going to sort of draw a line out pretty much in parallel with that. And then I'm going to need something to come down. This sloped roof is not going to be a great line because it's sloping. Um, but like this line here, this chimney line could be pretty good. I don't know where it's going to actually fall. I actually did a pretty good job, I think, of hitting it. So that vanishing point's here. This one comes here. This one needs to be longer, so I'll just trace it out a little bit longer. And we can see that according to this, it's right here. Now, I didn't spend a lot of time doing this method. The reality is, in the video, I do take more time to do it because I can tell that this vanishing point's a little high, and that's because I think see how I'm a little off there? That little bit over the short distance actually significantly changes the vanishing point. This one's actually pretty good up there, so I don't need to worry too much about that one. But that is one way of accurately finding on a building. Trace out two sort of parallel lines and find where they cross. I could go in the other direction too, but it'd be off the page. And then I could strike a line or just visually see where it is. So another way of doing it is to actually look at material. In this case, the building happens to have horizontal lines. So I know the material that lines perfectly horizontally must be at eye level, because the horizon line, any horizontal line at eye level is perfectly horizontal. We can see in the siding where I've got the light line there, it doesn't match. It's too low, right? If I come up high with this horizontal siding over here, we can see the horizontal siding doesn't match the guideline either because it's not correct. But as I sort of approach the correct horizon line, we can see the siding line, which is horizontal, is matched all the way across. So that is one way of finding the horizon line. And of course, a third way is not dissimilar to what we did in the photograph either, which I'm not going to do, but imagine a person is standing next to a building. Now, this is a bit tricky in this particular model, but if a person were standing here, their eye levels would hit a bit here. And I do know that this is the horizon line of the building, and pretty close to it. And I'll show you one more method after this of finding it. But I can imagine that this is a person standing next to it. Now, how do I know that? Well, one way is I'm looking at this door, and I know the door is about 7 feet tall, give or take. I know since I drew this one happens to be, I think, 8 feet tall, but 7 feet tall, give or take. So I can say, a person standing about here is going to fit through the door approximately visually. Well, if their head is up here, why am I saying the horizon line is down here? Well, the reason is that there's a couple steps up to this door. There's 1, 2, 3 steps up. So if I were to say put the person's head here and I go step 1 down, step 2 down, step 3 down, now their head is about here, right? And so how tall is a person next to this building? Well, estimate it based on a door or a window, and you will get it correct. Of course, inside a person's head will look out this window approximately here, which is where I want them to do, but I have to remember, again, that floor is 3 steps up. Another way of estimating it. Now, maybe the easiest way, if you have access to the 3D model, is actually to do it this way. I actually have the 3D model up, and when you have something like SketchUp like this, you might have the horizon line clearly shown, right? This is just the way SketchUp sometimes renders the horizon line. You can change the style of SketchUp if you need to turn this on, but we see the ground and the sky. And I don't have my scene saved up on the hero, but if I get close to the scene that I have right here, we can see that the horizon line is indeed pretty low on that window. But right here, and I can just visually say, oh, that's where the horizon line meets the building in this eye level shot. Right, so you can go and do that from your perspective and find it that way. And then once you're pretty close, again, you could come into Photoshop and strike a line to know where it matches. So now that I have the horizon line marked out of my building and the horizon line marked out of my ground, what I have to do is I have to make those two elements match. And usually it's by moving the building. Now, I just generally know visually that the horizon line is pretty low on that window, about midway through the door. So I'm going to take this horizon line away because I'm not going to need it. And all you do is you simply move the building till that horizon line matches where it should be. So I know the horizon line of the building is low on the window right here. And I know now in this image, the horizon line of this image is also right there, and they match. And so I've got it correct. So earlier when I showed the building down here, it was too low, and it makes this building look small. And when it was up here, it was too tall, and it just makes it look giant. It would be for a giant, right? But right there, the image is perfect. And I find so often, again, that students and young professionals, they don't do a great job of matching perspectives. But we'll see, especially for when we get into certain, if you're collaging a lot of elements together, like I'm just collaging two things, a site photograph and a building in this case, but you could get into Photoshop work where you have many, even potentially hundreds of things collaged in. They all have to match perspective, and you have to take the time to understand where the horizon line and or vanishing points are for all of those things to get them to match correctly. And again, just because it's in the computer doesn't mean it's going to do it automatically for it. You have to take control and get it done correct. So that's the basic elements of it. I do want to show one more thing and sort of as a summary about perspectives and Photoshop and basic collage work before ending this video. And that's about scale figures. I mentioned that an eye level image, an eye level of the person's going to be here. And if you haven't quite bought it, this is just an example. So I've just have this generic orange reddish person sitting out here just so I can really see what they are when I paste them in. And I'm gonna paste this thing in. It's gonna make a new layer. Of course, gonna put it centered so it's gonna be sort of be floating up there in the sky. And so where this person would fit, if I don't scale them, this person would fit there, right? So they're gonna be just right there. Their eyes approximately are gonna be there, and they sort of fits pretty good. And if I duplicate this, You can see how it goes. What I'm going to do is I'm going to just take this person, move it up. I'm just going to scale them decent amount and put it here. Hit enter. And I'm going to move that down. Again, I'm going to put their eyes, or where approximately their eyes would be, on that horizon line. And we can see that's basically starting to work. And I'm going to do it one more time at least. Duplicate layer here and make them really big this time off the screen. But when I pull it down, we can see, the eyes are going to be about here. And so I can see that the eyes of a person are always at the horizon line. Now, obviously, you can hang a person off the bottom, but here there's close to us. They're looking at this house. Here they're in the mid ground, and here they're sort of much further in the background. But their eyes, they're scaled differently, but their eyes are always on that level as long as they're standing on the ground. And that's why you can sort of estimate a person's height on either the background or the building and get it to work. Or more importantly, when you're putting entourage in your image, you have to make sure that your people eye level are always at this level. Of course, then give some variation for height of a person. And just to look at this, let's see, I'm going to duplicate one more time again here. I'm going to take this person, I'm going to put their feet basically at the base of I'm going to zoom in a little bit here. Base of the house. So let's just take a look at this. Come on, I'm going to put the little base of this house right there, approximately there. I'm going to shrink them down to their eye level, about there. So this person now, oh, I guess I shifted it off here. Let's move it, shift them even smaller here. Yeah, that's pretty good. So their feet is basically at the base. Their eyes are here. That means they're standing against the house that'd be about this tall. Just say again, if I did over here, actually, because the perspective, even this matters. Like, look at now this person is short. So actually I'm gonna just make them a little bigger to fit right at that area right there. And then if I were to shift them on top of the stair of where their platform would be, you can see they're fitting inside the door, just like I said, where their head should be. But it is the step 1, step 2, step 3 down puts them at that level. So just to point that out. So eye level perspectives are a great perspective setting to do renderings of architecture. For any perspective, you have to make sure you understand the horizon line of especially your background image, especially your building, and the people you put in it. They're all on the horizon line for eye level, and you got to match that perspective perfectly. Otherwise, it's going to look awkward and not look correct. So concepts of the perspective are clearly important. You'll see that in all the assignments we do in the class that this video was made for. It might seem complicated, but don't worry about it. You'll get used to it. It's not so bad. So good luck making great drawings.